So the ratio of 2 to 1 isn't exact. You might feel like it's too sticky, or maybe it's not sticky enough. So we're gonna add a little bit extra here. All right, and mix that together with our hands. And so this is a really cool slime. I like this one a lot. One that you often see is the borax one. There we go. We've got some cool snow, and I've got nice messy hands, which is always fun. And you can play around with it, and you can make really cool sculptures if you want. See, I'm gonna make a little snowman right here. If I can, snow person. Oh, actually, let's leave that there, a nice snowscape. Go. More there. Okay, there's the bottom part. There's the middle part. And there's the top part. And there's my snow person right there. Pretty cool, huh? And since it's not like real snow, it's not going to melt, it's not going to go anywhere, and you can keep playing with this forever. And if you keep it in a nice plastic bag, it's going to work out really, really well. Okay, so let's hop back to our other experiment there that we had. Now that I have my hands all messy, this is perfect. Okay, so take a look at the side of your cup. And at this point, it's still not doing great, but you can kind of move your finger along there, and you can see that condensation is starting to form along the side of our cup, right? So this might progress over the time that we have as we move through the rest of our time together. But yeah. So when we're looking at matter, when we're talking about that, we're talking about the atoms and the molecules moving around, okay? Let's get my hands cleaned off here real quick. Do a little bit of this. All right. So let's take a look at a molecule of water here. Okay. So you're going to have your H2O. So the O stands for oxygen. And your H2 stands for your 2 hydrogens right there that are connected. And as I mentioned, it's kind of like a magnet. So you have a positive end down here and a negative end up here because of how they share their electrons. So the oxygen actually kind of steals the electrons from the hydrogen, so it's kind of like a magnet. So the oxygen end is going to want to stick to other oxygen, or it's going to want to stick to where opposites attract. So you'll have them kind of join together in this fashion. You'll have one kind of sticking to the edge of the other. Well, when you add energy to those, they don't want to stick together as easily. So in a liquid state, they're going to kind of flow over each other. As you get to a solid state, and this is a cool property of ice, is that they actually start to form a kind of a ring. So you have the atoms kind of all around there, and that's why water is less dense, because there's this space in between, whereas most of the time when things come together, they slowly come further together rather than start to come apart at a certain point. But they're all made of atoms and molecules. And in this case, water is a molecule because it's made of 2 different kinds of atoms. We have oxygen here, and we have our hydrogen here. Okay. And so as we change those states of matter, we move from a solid, which is our most common one. Solids are all around us. We rely on them in order to live our lives. Liquids, that's the second most important one. That's because we need to take in water. And then gases, which is the most important. because we need to breathe every second of every day. So we'll kind of, I guess, keep taking a look at our experiment as we go over. But I think at this point, I'm going to put on my crown. Where'd it go? Where'd it go? There it is. I'm going to put on my crown, get myself ready for the countdown, and I'm going to turn it back over to Stephen. Thank you very much, everybody.
All right, awesome. Thank you, Ben. So now what we're going to do is on the topic of ice and water and snow. Our last experiment before the countdown is going to be about snowflakes and the science of snowflakes and their structure and how they're made and stuff like that. So I know you're all very familiar with snow at this point, at this time of year. I know I am. My back is still sore from shoveling all 3 feet of it a couple of weeks ago. But what most people know is that every snowflake is unique. No 2 snowflakes are the same. They always have a cool, unique pattern to each of them. And so, how are they made? So, just like rain, it starts in the sky, in clouds. And so, what happens is there's little dust particles that are suspended in the clouds and in the air, in the atmosphere. And those are the seeds of the snowflakes. And so, high up in the clouds, we were already talking about this with Ben, with the water cycle. Water starts to condense onto those tiny little particles, just like it condenses onto the surface of your cups during that experiment. And so this water condenses on these dust particles and it freezes. And so that happens and it forms a small ice crystal over that seed, which is the dust particle. And so what happens is even more water condenses on top of that crystal, creating an even larger crystal, and it just repeats and repeats and repeats as it grows into a nice structure. Now, there are several different kinds of snowflakes, and right now we're gonna see some of the different kinds. So right here, we have a nice graph that explains the different kinds of snowflakes and in what types of situations they form. So on the vertical axes, so on the side, you see a word that says supersaturation. That is basically just another word for how humid it is or how much water vapor is in the air. And on the bottom, you have the temperature. Notice it's nice and cold. You have -30 degrees Fahrenheit all the way up to freezing. So that's the nice little area right there. And depending on the humidity and depending on the temperature, you'll get different kinds of structures and different kinds of snowflakes. And so the ones you'll probably easily recognize are called plates, but there are also needles and columns, which you might not recognize, or solid plates and kind of the cool stuff like that. Here's another image of other different cool kinds of structures. We have the plates on the top, but going down, it just gets weirder and weirder. We also have irregular particles, which happens if not a really good crystal forms. And we also have hail on the bottom. So that is a different kind of precipitation. Hail and sleet happen in different kinds of weather. We won't be talking about them right now, but we will focus on the snowflakes. Now here we have actual pictures of real snowflakes. Using a special type of camera, they're able to zoom in really close to the snowflakes and see exactly the details of all the snowflakes. So here's one. Here's another. And here's another one. And see, they're all different. And also notice that all of them have 6 points to them. They all have 6 points. See? Now that is no coincidence, as due to the structure of the ice crystals, just like Ben was talking about, how they form in rings, all of the ice crystals, they form in hexagon structures, and hexagons are 6-sided. And that has to do with the structure of the water molecules. And so most snowflakes you'll see in these plate patterns will be 6-pointed. However, This right here is a rare type of snowflake that is 12-sided. Now 12 is just twice as much as 6. And so basically what you have here is having 2 of the segments growing off of each side of the overall crystal structure. So 12 is rare, but it is possible. 6 is the most common you'll see. And here we have a really cool picture of a column type of snowflake, which you might not realize are actual shapes of snowflakes, but this is a relatively common type. And right here we have a really weird one, which is a combination of a column in the middle and 2 caps on the ends that are regular plate ones like you would recognize. So it's a capped column snowflake. And here's another picture of one of those. And you can see in the previous picture that even those caps on the ends are still 6-sided. Oops, went too far. So now what we're going to do is we are going to figure out how to make your own snowflakes. And so here's our activity. Let me switch cameras for you real quick. And so now for our final experiment, we will need your piece of paper that you have. It doesn't have to be this type of paper. It can be really any rectangular or square piece of paper you have. You'll need your scissors and you'll need a pencil. So I'll let you get those if you have them. And what we're going to do is we're going to create the most common type of snowflake, which is the 6-sided one. And so it needs to be folded a special way. And I'm going to show you exactly how to do that so you can make them at home. The first step, though, is we need to make this rectangular piece of paper into a square. Now, the easiest way to do that, if you have a square piece of paper, you're good to go. You don't have to worry about this. But if you have a regular piece of construction paper or printer paper, you'll need to follow these instructions. So what you'll want to do is have it like this. Take one of the top corners and bring it down until this edge of the paper is even with the bottom edge right here. And have it nice and even. And there will be this excess paper right here. And if you fold this, it'll make 2 equal triangles, which means that you have found yourself a nice square. So make a nice crease right there. Remember, there's going to be a little excess paper right here. But the important part is that this edge right here is nice and lined up. So have that be a nice crease. And the first step, what you're going to do to make it a square is just cut along here. Cut this excess strip of paper off. So let's do that. All right. And this paper, you do not need anymore, so you can set that off to the side. So now, if you notice, if you unfold that piece of paper, you now have a nice square piece of paper. So the good thing, though, is that that fold is the first step in creating our snowflake anyway. So keep that nice and folded. Put a nice crease in it because it's going to stay folded and we want a nice tight fold. Now the next step is another easy fold. All you're going to do is make that triangle and just fold it in half again to make another triangle. And again, make that a nice good crease right there. All right. And just to make sure you did it right, if you unfold it, now you have a square piece of paper with just a nice X on it. 4 segments. All right, make sure that's nice and even. Really press down good, get those creases really tight. And now this next fold, it's a little tricky. I will admit, it usually takes me 1 or 2 tries. But that is okay, because we're going to do it together, and it's going to be great. So the goal right now is to fold these two ends inwards like this, and basically separate it into 3 parts and make a new triangle that is like a third of the size. And so what you're going to want to do is take your paper and kind of try and eyeball it, where you fold over maybe a third of the piece of paper. And you don't want to do a really firm crease yet because you don't know if you really got it right. So just kind of, fold it a little bit and take your other end and fold over that like this and see if it lines up. See, mine is a little short, I've noticed. You can see if you did yours a little short, if you line up the sides, there's a little nub right here. You don't want that. So I actually have to come in a little farther on this fold. See how that works. Oh, still not enough. That's all right. Just keep moving it in a little bit by a little bit. Now see, I went too far. Like that. I'm going to bring it back. Now you see why I said it was tricky. But now it looks like I did it pretty well. Now, if I fold that over, you'll find yourself, you made a sort of a little arrow. It's nice lined up a little bit, right? Works out nice. And now once you have it well done and the edges lined up, now you want to press down and really make sure you get it nice and creased. Press down nice and good. Now, just to recap, I'm going to unfold mine just to show you. So we have our square. We fold it over once to make a big triangle. We fold it over again to make another triangle. And then we did that weird trifold right there to make a nice arrow. So hopefully now that you have that, our next step is another cut to cut off excess paper. If you flip it over, you'll find that there is a line in the paper right here that is flat, and you basically want to cut off these 2 points right here. So go ahead and just cut right along there. Like that. So now you have a nice triangle right there. And now comes the fun part. Now comes the part where it can get a little fun and you can make it unique. So this is where we start to design. So take your pencil. And I'm going to do my own design. You can use my design if you want, but I encourage you to do your own. Because remember, all snowflakes are unique. And it's fun to make your own patterns. But I'm just going to do a really simple pattern with some straight lines. So draw along the lines that you want to cut out. And I like to put a little X in the areas that I want to cut out so I know which spots to keep. So maybe something like this. Don't have to put too much thought into it. There you go, that's a good view. So now what I'm going to do is I'm going to cut along those lines and cut out the areas that have the X's in them. Now be careful because now there's so much paper folded up that it'll be a little hard to cut. So you have to be a little firm with it. Once you cut a piece of paper, it'll kind of fall apart into a bunch of pieces. So set those aside. All right. So this is what I end up with. It's a cool little design. Now the last step is you carefully unfold it. The more things you cut in it, the more delicate it's going to be, so be careful. But if you unfold it, you should find that you made a nice 6-pointed snowflake of your own design. Now, because it was folded up so much, it's going to want to bounce back and fold back up. But if you take a bunch of heavy books and you set them on top of this and wait a little while, it should flatten out pretty nicely. I made some other snowflakes earlier just to get you an idea of some of the potential for some cool designs. So I encourage you to try this again on your own and make some cool snowflakes, and they're great for decorating around the house during the wintertime. All right. Were people successful with their snowflakes? Hold them up to the camera. Let me see them. Oh, I see some really good ones. Awesome. Those look great. Very cool. Good job, guys. So remember, if you want to do that again, square piece of paper, fold once, fold again, and then the weird trifold. It takes some practice, but I'm sure you can get the hang of it. All right. So now we have finished up our experiments for the day. Let me switch cameras. And I hope you guys enjoyed today. Before we do our countdown, I would like to do a little bit of advertisement. So I'm going to share a screen.
Oh, before we do that, could I teach everyone a quick dance?
Oh, absolutely. Let me put the focus on you. There we go.
All right, friends. So since I've been talking a lot about matter, we've been talking a lot about matter and different states of matter. I thought I could teach you guys the matter dance. It kind of helps you remember what the different states of matter are. So if you want to participate along with me, you're going to want to stand up. You're going to have your feet very together, and you're going to put your hands up just like this. All right. Can't see if you're doing it, so I'll just keep going along. So solids, as we mentioned with that, it's all about the energy of the molecules, of the atoms. Okay, so solids, you can't see it, but they are moving around. So we're just going to move our hands around just a little bit. This is just the small vibrations that you get from the atoms in a solid, right? Now, we're adding energy. You add temperature, heat, and that's just a form of energy. So what happens is we add a little energy, and now, as we move from a solid to a liquid, we have a little bit more flow. But we're still we don't move around too much. We've got a little bit of extra movement here, but we have to kind of stick to each other, right? But if we want to move into a gas, we got to add a little bit more energy. So let's add our feet to this. We're going to go back and forth. They move around a lot. They bump against each other. They're really low density, and they got that. But there's one more state of matter that we have to go through, and that's a plasma. Sun is made out of plasma, but if you have fluorescent lights like we do, that's a cool plasma. And it's when you get a lot of energy in there, and it's so the place your electrons are flying everywhere, and you don't know where they are, but that's okay because they'll come back as we lose our energy back down to a gas. We lose energy back. We're losing more energy. Lose more energy back into a solid. We slowly get colder and colder and colder until we reach absolute zero. And there's no molecular motion at all. But we're not at absolute zero, so let's move back into our solid state, back into our movement here. So that's the matter dance. Glad you were here to learn that. Back to you, Stephen.
Thank you. So now what we're going to do, we're only 3 minutes away. Only 3 minutes away from noon. So what we're going to do is we're going to have a countdown. So let me get this set up real quick. Let me bring up a clock. And here we are. This is our time right here in Schenectady. The cool thing about this is that now that noon is only a couple minutes away, that means that it's almost midnight on the opposite side of the earth. So the days on the earth are created by the spin of the earth. The fact that the earth spins and different sides get the sunlight at different times is what creates the sunrise and sunset and the nights and the days. So while one side is facing the sun, it's daytime. The other side, on the opposite side, is facing away from the sun, so it's dark and it's nighttime. So if one day is 24 hours long, then that means halfway around the earth, on the opposite side, it'll be midnight on that time if it's noon on one side. So at any given point, the side of the earth that is opposite yours is 12 hours ahead. So this morning, Australia already had their New Year's. It was already midnight, it's already come and gone. So Australia and eastern parts of Asia are already in 2021. So right now, as we're counting down to noon, it's actually going to be counting down to New Year's in places like Indonesia, Thailand, parts of Russia, Mongolia, places like that are on the opposite side of the earth. So this online clock gives us the exact time, and we're less than a minute away from noon. So we're getting really close. I want you all to count down with me, along with me. We're only 30 seconds away. Get your decorations ready. Time to get excited. I know everyone else on the opposite side of the earth is getting the fireworks ready. The ball is dropping in Thailand, in parts of Russia. We're only 15 seconds away. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Happy New Year! Woo! Happy New Year's! Set off the confetti if you got them. Hey! Woo! Woo! All right, so the new year just happened on the opposite side of the earth, and the noon year just happened right here. So here we go. Set off for confetti if you got them. Woo! There we are. It's partying here. All right. So I'm so glad that you could all join us for this. It has been a lot of fun. I hope you guys liked it. This is our second annual New Year's Eve celebration, so hopefully we'll have it again next year. If you like this celebration, please keep in mind that our museums, even though they are closed in person, are still open and doing virtual things. Here are our information, our websites, and our social medias. Before I hand it over to Ben to talk about CMAS, I would just like to make a note that miSci is closed, but we are offering virtual science and engineering classes for children of all ages. So if you have a group that you want to register to have a class taught maybe by me, maybe by another educator, please visit that link right there and check it out. You can become a member or make a donation at that link. And if you guys have the things that you made today, the snowflakes or the cups with the water in it and the salt water, all the things you made, the colored in penguins, we'd love to see them. So if you want, post them on social media, tag both of our museums in them so we can see them. And we really appreciate that. Ben?
All right, everyone. So at the museum, we have lots of really cool things going on. You can visit our website just to kind of check things out. You can visit our Facebook. We're always posting stuff up there. We have events. We have videos that we like to share. Same thing on Instagram. And if you go to our YouTube channel, we have a lot of videos that are kind of compiled there for you to kind of check out. And we're working on them all the time. We have weekly programming. Right now we have Tuesdays and Thursdays at 10:30. On Tuesdays, we have story time, which is a story and a craft. And Then we have on Thursdays, we have Science Explorers, which is kind of a little bit along the lines of what we did here today. It's an experiment that you can do at home. We actually give you all the materials that you need. And you can sign up for that by getting a hold of Jessica. Either you can email her at education@cmssny.org, or you can give us a call at 518-584-5540. And, you know, I hope that we get to see you in person soon enough, but until then, I hope that we get to see you online and get to educate you and have a great time. Thanks.
Awesome. Thanks, Ben. Once again, thank you all for coming. Thank you for CMAS, the whole team over there. It's been a great time planning this event and running it with you guys. And for everyone who joined us, thank you all again, and enjoy the rest of your New Year's Eve. Thank you.
Thank you.
Thank you.
Thank
Happy New
you.
Year.
Everyone.
Well, thank you.
Bye.
Bye-bye.
Thank you.
Happy New Year.
Happy New Year.
Happy New Year.